We are going to look at question 15 from the in-class worksheet that we did for sections 1.4 through 1.6. Question 15 asks us to solve the equation by making an appropriate substitution. So this is an equation, 6x raised to the 2/3 power minus 41x to the 1/3 minus 7 equal to 0. This equation is what we call one that is a hidden quadratic, or an equation where if we make an appropriate U substitution, we can rewrite it in the form of a quadratic equation. So just to kind of review, our quadratic equations are in the form of ax squared plus bx plus c equal to 0. So looking at what we have here and kind of comparing the two, we have 6 would be our a, and then we have our x to the 2/3 instead of to the second. We have minus 41x to the 1/3 instead of x to the first. And then our constant. So the constant part really isn't going to have anything to do with what we're trying to do right now, other than, we will need it when we go to solve the quadratic and so forth. But what we're trying to do right now, in a sense, we're talking about hidden quadratics. The easiest way to solve these and to think about it is going to be to look at this bx, okay? This term, x is to the first power, okay? So when we go to make the U substitution, what we want to do is take this, and instead of x, because we're substituting in a u, it's going to be something that's like a u squared, oops, it's a little thick there, u squared plus bu plus c equal to 0. Well, if we're trying to figure out what to plug in for u, we're going to look right here at this second term. And that's really going to drive it for the hidden quadratics. So if we say, for instance, let u equal x to the 1/3. Well, let's see what happens when we plug that in. For this first term here, where we have 6x to the 1/3, if we express it as 1/3 instead of the 2/3, well, we can use our power rule to say, hey, if I multiply by a 2, basically over 1, essentially, right? If we multiply this, we get back our x to the 2/3, right? That we had above. So we can express it, and I'm going to take that little 2 over 1 off, as 6 times x to the 1/3, and then that's squared. Okay, looks good so far, right? We're going to do minus 41. And then the x to the 1/3, I'm just going to put parentheses around it. I'm going to say minus 7 equal to 0. Well, if we scroll down a little bit here, let's see. Everywhere we have this x to the 1/3, we're going to say this is now my u, right? So I have 6u squared minus 41, and this again is u, minus 7 equals 0. Well, look, we did it. So what we are doing right now is we're really trying to rewrite something that looks similar to our quadratic, but it's not in a quadratic form. By creating an appropriate substitution, we can then write it in terms of u in the quadratic form. Now we can choose a strategy to solve that quadratic. So for this one, we have 6u squared minus 41u minus 7 equal to 0. Looking at it, the first thing I see is 6 and 7. If I multiply those two, I get 42. And that's 42 times 1. The difference there would be 41. So my mind immediately goes to factoring. If you're not comfortable with that, you can use the quadratic formula. You can do the AC method if you do kind of think that it might be factorable, which it is. So I am actually just going to go ahead and do a trial and error approach, or I can kind of see that as I'm looking at it. So I'll try and explain it as I go, but if you're not comfortable, definitely you are able to use quadratic formula, or you may use the AC method. But my thinking here, like I said, 6 and 7, when I multiply those two together, I know it's 42 or negative 42, right? And I know I want 1 and negative 42. Well, 7 only has 2 factors. It has 1 and 7. So I'm just going to put a 1 and a 7 in here. And then I know that, oops, I did something funny. I know that in order to make a negative 42, I need to multiply 7 by my 6, right? Okay. So I'm going to put my 6u here, and I'm going to put 1u here. Now this is going to give me that inner and outer product that I need. I just need to put some signs because, and I'm going to change this color actually. 6u and 7 gives me 42u. I know I want that to be negative, right? So I'm going to put that sign here on the 7 because that's driving this. The 6 is positive. And then for my second, my inside, I'm going to do 1 and 1. Gives me my 1u as well. And we know we want that to be positive. We already said that over here. So I'm going to put a plus. Now, if you've never done things this way, or if you're not sure, that's fine. You can use any of the other methods. If you are one of my folks who want to go on and do some of the more difficult, like pre-calculus, calculus classes, I recommend maybe becoming comfortable with techniques like this. But now that we're here and we have our two binomial factors, I know that those are still, so I had 6u, I kind of took an aside there, 6u plus 1 times u minus 7 is equal to 0, right? Coming down, I'm going to solve these two using the zero product property. 6u plus 1 equal to 0, u minus 7 equal to 0. My first factor gives me u is equal to negative 1/6. My second factor results in u equal to a positive 7. Now, we always want to think about what's been going on because it's kind of a long process, right? When we started, we had x. We substituted u for x, right? Well, now, when we get down here, we're going to kind of take this the other direction, right? We're going to keep going down. And now we're going to back substitute or reverse the process and say, hey, again, we're going to let u equal x to the 1/3. So we're going to now plug back in where we see u and say this right here was u. So it's going to be x to the 1/3 is equal to negative 1/6. Similarly, this was u is equal to 7. And that's going to kind of be my second over here. X to the 1/3 is equal to that positive 7. Now, to solve for x, because we do want x to the first power, we will take both sides and raise it to the reciprocal of that, or raise it to the third power. That's going to give me x is equal to negative, let's see, 6 to the 3rd. Six raised to the 3rd power gives me 216. Keep in mind this was negative. I didn't put negative in on my calculator, but if you're going to do it, make sure that you have that negative sign. 1 over 216. And over here, same thing, raising this to the reciprocal of that power. 3 over 1 or 3 would give me x is equal to, and once again, 7 raised to the 3rd would be 343. So you now have two values for x that we have found by substituting in for our original equation. Okay.